Today we're going to take a look at law of sines again, but this time with a special case where we have two sides and an angle not included in between them. You might remember from geometry, you learned several like SSS, ASA, and so on, SS or and remember, SSA is not on the list of triangle congruence theorems because it's possible to create two different triangles, same description. For example, if I had a triangle with a 20-degree angle and let's say a side of 5 units long, 1, 2, 3, 4, 5 units long, and let's say I have another side of 3 units long. That would be right there. So there is a triangle that has a side of 3, a side of 5, and an angle of 20 degrees. Now notice that I can also draw a triangle that has, if I take this side that's 3 units long and I swing an arc over to here, you see there's another triangle, this red triangle, that has a side of 5, a side of 3, 1, 2, 3, and an angle of 20. So we have the blue triangle here. We'll call that triangle ABC. And the red triangle ABC, which both have sides of 3 and 5 and an angle of 20 degrees. So there are actually two different triangles that meet that description. So that's why SSA is not one of the triangle congruence theorems, because it doesn't guarantee that the two triangles will be exactly the same. So what we're going to look at today is the applying law of sines when we do have the SSA case, because there may be more than one possible outcome, as I've shown here with the blue triangle and the red triangle. Go ahead and take a moment and copy down the information that's here, because we'll be referring to that as we go through the next few examples. So applying step 1 from above, notice that we do have two sides and an angle not in between them in this case. So we have some triangle A, B, C. Side A, which is across from angle A, is 6. Side C, which is across from angle C, is 8. And we have an angle of 30 degrees. Angle A is 30 degrees, and it is not between the two sides. So that is an SSA case that we have. Two sides and the angle not in between them. So step 1 from the list of steps up above says to go ahead and apply law of sines. So we would have A over sine A equals C over sine C. And so we'll have 6 over sine of 30, and we'll have 8 over the sine of angle C. We know the sine of 30 is 1/2, so this is 6 over 1/2 equals 8 over sine C, which if we cross multiply, we get 6 sine C equals 4. Sine of C is equal to 6 over 4. Sorry, 4 over 6. And then C would be the inverse sine of 4 over 6, which is, using your calculator, is going to give you 41.81 degrees. So now if we say that C is 41.81 degrees, we see that it is possible to find the third angle B. Angle B would equal 180 minus 30 degrees minus 41.81 degrees. So that tells us that angle B is equal to 180.9 degrees. Now the only thing left to do is to find side length B. And so we can use one of those signs again. We can say for the sine of 108.19 to A, 6 over the sine of A, 30 degrees. And so since sine of 30 is 1/2, we get 1/2 B equals 6 times the sine of 108.19. Multiply both sides by 2 and work that out on your calculator, and you get B is equal to 11.4. So now we know all the missing pieces of the triangle. We got angle C is 41.18 degrees, side B, or angle B is 108.19 degrees, and side B is 11.4. So we were given 3 pieces, we found the other 3 missing pieces. Okay, so we've completed step 2 on the 4 steps above. Now we need to see if there are additional solutions. So what we do is take our original answer that we got from from step 1, and that is take our 41.18 degrees and see what happens if we take the supplement of that. So step 3, we're going to take the supplement of angle C, 180. Let's say C is 180 minus 41.81, and so that would tell us that C is 138.2 degrees. Now we're going to see if it's possible to make a triangle with these measurements. Angle, we already know angle A is 30 degrees, so we have a new drawing now. We have angle A is 30, angle C is 138.2 degrees. Obviously I don't have a scale drawing because that doesn't look like an obtuse angle. And now, is it possible to find angles, angle B? Angle B would be 180 minus the 30 degrees that was given, minus the 138.2 that we got from the step above. So angle B in this case would be 11.8 degrees. And so that looks like that is possible, 11.8. As long as we don't go over 180 degrees, then we know we've got another possible outcome. And so now we're ready to find our new side B. So we'll do side B over the sine of angle B, which is 11.8, equals 6, that's A, over the sine of A, which is sine of 30 degrees, or 1/2. And so we get 1/2 B equals 6 sine of 11.8. And so B then is 12 sine of 11.8, which if you type that in your calculator, you end up with B equals 2.5. which gives us our third solution. Okay, so in this case, our second solution. So there are two possible triangles that fit the description that was given. So we have our original solution, which I stated above, and then we have our new solution in which angle B is 11.8 degrees, side B is 2.5 units, and angle C is 138.2 degrees. Okay, so two different outcomes given the same description. Go ahead and give example B a try. Pause the player, see if you can go through steps 1 through 4 above, and then start the player again when you're ready to see the solution. So we'll go ahead and start this one using the law of sines again to find angle C. So we'll do side A, or the sine of A equals side C over the sine of C. When you cross multiply, you have 8 sine 30 equals 4 sine C. So we have sine of C is equal to 2 sine 30, which we know is 1/2. So that would be 1. C is equal to the inverse sine of 1. Don't even need your calculator for that. Think of an angle on the unit circle where the y value is 1, and you'll know that C is 90 degrees. And so if we have an angle of 30 degrees, an angle of 90 degrees, the other angle, angle B, has to be 60 degrees. And now all that's left to find, well, we actually know this is a 30, 60, 90 triangle, so we could either go back to law of sines to find our missing side, or we could realize that A is a 30-degree angle, B is a 60-degree angle, and angle C is the 90-degree angle. So what do we know? We know the hypotenuse is 8. We know that side A is 4, so that makes this side 4 root 3. Okay, so we have side B is equal to 4 root 3, which is about 6.9. Okay, so we found all the missing pieces that we need. We're done with step 1. So all step 1. Now step 2, are there other solutions? Let's check. If we take the complement of angle C, the first angle that we found, using law of sines, what if C was equal to the complement of 90? 180 minus 90 is 90. Well, we see that we get the same answer. So if angle C is the same, angle B is also going to be the same, and side B will be the same. So there is only one solution. No, only one solution to this problem. Now go ahead and try example C. We'll start the problem the same way as the other two. A over the sine of A is equal to C over sine of angle C. Cross multiply and we get 3 sine C equals 8 sine 30. We know sine of 30 is 1/2, so this side we get 4. We have 3 sine C equals 4, so sine of C equals 4/3. And if you try doing C is equal to the inverse sine of 4/3, if you try that on your calculator, you'll get an error. And that's because we know from the unit circle, the sine function, which is always the y coordinate on the unit circle, can never be more than 1. Our circle only has a radius of 1, so how could we possibly have a y value up here bigger than 1? And since 4/3 is bigger than 1, there's no solution. So if we can't find an angle C that works for the problem, then there's no solution. So it's impossible to draw a triangle with these measurements. All right, a couple more examples to go. Okay, this time angle A is 140 degrees, so we'll say side A over the sine of 140 equals side C over the sine of C. Cross multiply, 10 sine 140 equals 8 sine C. And so the sine of C is going to equal 10 times the sine of 140 divided by 8. And if you type that in your calculator, actually we're going to take the inverse sine. We're going to say C is the inverse sine of 10 times the sine of 140 divided by 8. Make sure your calculator is in degree mode. And if you type that in, you'll see that angle C is 53.46 degrees. Now, is that possible? So let's take a look. We have angle A is 140. Angle C is 53.46. Well, we're already over 180 degrees. So this is impossible. So we get another impossible case, no solution. Go ahead and try this last one on your own. Pause the player, work out the problem, see how many solutions you get, and then press play again when you're ready to see the solution worked out. Okay, so we'll start with A for the sine of A equals C over the sine of C over the sine of, sine of C. So if we cross multiply, we get 12 sine C equals 9 sine of 125 degrees, which means C is equal to the inverse sine of 9 sine of 125 divided by 12. So we're going to type that into the calculator and get C is equal to 37.9 degrees. Now, is it possible to have a triangle with an angle of 125 and an angle of 37.9? Yes, it looks like we're not over 180 yet, so now we can say that angle B is equal to 180 minus 125 minus 37.9. We get angle B is 17.1 degrees. Now we just need to find side B. So we'll say B over the sine of 17.1 is equal to C, which is 9, or actually let's use A. A is 12 over the sine of 125. And we get B is equal to 12 sine 17.1 over the sine of 125, which is 4.3. So we did find one solution. We got C, B, and side B. Now let's check and see if there's another solution. What is the supplement of the answer that we got for angle C? So we've done step 1, ready to try step 2. What if we said C was equal to the supplement of 37.9? Now we get 142.1 for angle C. And is it possible that we could have a triangle with the angle A that was given, 125, and the angle C that we just got, 142.1? Obviously, we can't have two obtuse angles, so this is not possible. The supplement didn't work out in this case, so we only get one solution. And that completes the notes on lesson 5-7.